So this is our third day. So welcome everyone. Today we start with the guest speaker's talk. So as we have done yesterday. So today's speaker is Thomas Davidson, or Tom. So I'm really pleased to have Tom as our guest speaker. He's one of the kind of leading, maybe like emerging stars in computational science. So Professor Tom Davidson is an assistant professor in the Department of Sociology at Rutgers University in Brunswick. He received his PhD in sociology from Cornell University in 2020 under the supervision of Michael Massey. His research interests include political sociology, social movements, and the sociology culture, I think, which will be very much intersecting with our own. And his research uses digital trace data from social media and other websites combined with statistical analysis and computational methods, including NLP and machine learning. By the way, he is a member of our SICSS community. He was an alumnus of 2019 Princeton, and also was a co-organizer of the Tucson location, right? So he's really actively working with the SICSS community. So I'm really happy to bring him in here, possibly make virtual connection with us. So please join me welcoming Professor Tom Davidson.
Well, thank you, everyone. Good morning. Thank you for the very kind introduction. So can everyone hear me okay? Great. Okay. So my talk today is going to be focused on some work I've been doing on the topic of hate speech detection. And I'm really going to focus on two main areas during this talk. I'm going to talk about some research focused on the detection of hate speech on social media using machine learning. And then I'll talk about some other work I've done looking at the issue of racial bias and how these machine learning methods can end up having discriminatory outcomes. And I'm going to end by very briefly touching on some work in progress I'm doing using some experimental methods to kind of dig deeper into these problems. I'll just preface this by saying I'm a sociologist by training. This talk is going to be much more in the area of natural language processing and computer science. And towards the end, we're going to perhaps move it a little bit into some psychology. I'm working on kind of building in a more sociological component to this research, and you might see that come through in the kind of future work I'll discuss at the end. So detecting hate speech is a very hard problem. It might seem easy. It might seem like, well, we just know when we see it, and if we just see some hateful words like slurs, that something's hate speech. But as it turns out, it's probably more difficult than you think. Mark Zuckerberg famously said that it's easier to detect a nipple than it is to detect hate speech with AI. One of the reasons for this is we can get lots of pictures of nipples and train a model for nipple detection and build some accuracy. And while there may be debates around which kinds of nipples are acceptable on which social media platforms, it's generally agreed upon what constitutes a nipple, whereas hate speech is much more subjective and difficult to agree upon. And this area of research has really exploded over the last several years. I first started working on this topic around 2014-15, and at the time there was very, very little research. There were 1 or 2 papers looking at this problem, and since then it's really grown as an area of research as well as a kind of emerging social problem that now, fairly regularly there are news articles in the media about things like online hate speech and harassment, and it's become a very large global social problem. So hate speech itself is a difficult concept to pin down. And in part, this is because there are many different ways of defining hate speech. And I'm not in this talk today going to give you kind of one canonical definition, but I want to talk about a few different ways that we can think about hate speech. So in some countries, there are legal definitions where there are certain kinds of speech, usually speech that attacks certain people based on some sort of demographic status, often directed towards minority groups, and these speech acts are illegal. This is the case in places like Germany, for example, which for obvious reasons has a kind of relatively recent history where there are certain symbols and speech acts which are punishable by law. In other countries like the United States, most speech is protected by the First Amendment. Social media platforms have developed their own policies, and these are really policies that are constantly adapting to the realities on the ground. And if you look at the policies that Facebook or Twitter had in place 5 years ago, or even 1 year ago, they're likely quite different to what they have in place today. Academics, particularly academics kind of working in the more legal tradition, have come up with various different definitions of hate speech. And then we also have our own common sense definitions of hate speech, which have become something of a political controversy, particularly in the United States, of the last few years, where you have people, particularly on the right, who really have a very high bar. They claim very little is hateful, that you have a right to say what you want. And then you have other people who want certain types of speech to be really controlled and policed in many settings, including on social media. So how can we go about detecting hate speech? Well, once we've agreed upon some sort of working definition, we need some methodology for detecting hate speech in text. And primarily, I'm going to be talking about text today. There's work looking at detecting hate speech in oral recording, speech, videos. I'll touch briefly on images, but I understand you'll be covering some of these methods later on this week, so I'll be focused primarily on text. And the simplest way to do some sort of text classification is to use a dictionary or a lexicon. So we come up with some set of words that we think are potentially indicative of hate speech, and then we go and we detect content that contains these words. There are various different ways of coming up with dictionaries. I'm happy to talk about this in the Q&A. Something that we used in our work is a resource called HateBase, which is a crowdsourced dictionary of hateful terms. You can see some of them here. And so by constructing a very large dictionary, we might find a huge, huge array of words that are potentially hateful or offensive in certain contexts. The problem with dictionaries is they tend to be very, very low precision. So they can be high recall. And I use this metaphor of like a trolling ship. That let's say you want to go and catch some tuna, you can use a big net and drag this huge net through the sea. And if your net's big enough, you're going to catch all the tuna. So in this case, if your dictionary is large enough, you're going to find potentially all of the potentially hateful words. But you're going to drag up everything else in your net. You're going to catch the dolphins and the sea turtles and all of the other fish you don't want. So you get this kind of bycatch. And so these methods tend to be very low precision. So the goal of a lot of my work in this area is to think about how can we improve our precision and use a method more like this, where fishermen are using a pole and line to catch the tuna they want and to leave the sea turtles and the dolphins and everything else in the sea and not cause any problems for, in this case, people who are not using hate speech. So how does it work if we want to use machine learning to train a classifier to detect hate speech? So the idea here is that if we use more information about social media content, rather than just simply making decisions based on words they contain, that we might be able to come up with more nuanced models that are better at distinguishing between hate speech and other kinds of content. And so the way that this typically works, and this is really a very standard type of machine learning workflow, is we start with some corpus of social media posts. Perhaps we collect lots of tweets from Twitter. We read those posts and annotate them and decide with human annotation which ones are hateful and which ones are not hateful. We then construct some numerical way of representing these texts using various different kinds of features. And then we train a classifier to use these features to predict the annotated labels. And the idea is that we can train a machine to do the same task that a human annotator might perform. And I'll walk through each of these steps in a little more detail. I'm sure you're covering some of this material in the next couple of weeks. So first, the annotation procedure. Annotation, I think, is often a little overlooked in machine learning research. People often want to get to the stage of developing a new fancy model. And it's something that we're only more recently starting to pay more attention to. And as I'll mention later on in this talk, annotation can potentially be a source of lots of issues that arise with hate speech detection models. So the way annotation works is we start by sampling some data. We then design an annotation scheme. So in the case of my work on hate speech detection, we come up with a set of instructions that annotators could read to allow them to distinguish between hate speech and other kinds of content. When I conducted my research in this area, we're using a platform that's no longer operational, something similar to Amazon Mechanical Turk called Crowdflower. And so you design an annotation scheme, and then you annotate data. And so we were paying crowd workers to look at tweets that we had collected and to determine whether those tweets were hateful. You then have to conduct some sort of reliability check. This is very important to make sure that annotators are agreeing and that the labels are actually meaningful. And I would encourage all of you, if you ever do an annotation task like this, to really do a lot of iteration to make sure it's working well. So you could start with a small sample, code them, and then discuss any disagreement and make sure that you have a scheme that people can understand and easily apply to new text before you spend a lot of money annotating a large corpus. So in my work in this area, we annotated approximately 27,000 tweets that we had collected. These tweets had already been collected based on containing one or more keywords from the hate-based lexicon. So once you have your annotated corpus, what we then want to do is to construct some sort of features. Features is machine learning terminology for variables. If we have a document like a tweet or a Facebook comment, how can we represent this in a way that allows us to input it into a machine learning model? And there are various different kinds of features we can use. We can use bag of words and engrams. These are just sequences of words. We can use things like part of speech tags. So whether something is a noun, whether something is a verb, is there a certain pattern of syntax that we can capture that might be indicative of hate speech. In some of my work, we tried things like sentiment analysis, readability scores, which gives you some proxy for kind of how well written something is. And more recently, this area has really moved on to vector-based representations. These days, if you're starting a new text classification project, you're likely going to be starting with something like Word2Vec or even a BERT model or a more advanced transformer model where you just have this huge pre-trained language model and you vectorize your texts and use this pre-trained language model, perhaps with some fine-tuning, to train a set of features to use in your model. So there are many different ways we can represent these texts, and other things we might want to do is to also encode some other information about, for example, the individual user who wrote something, or their social characteristics. So for example, something like network size. Is someone very popular online, or are they kind of a marginal figure in their community? Maybe that gives us some insight into the language they're using. There's been a lot of research in this area covering an array of different features. And so once we've got our annotations and we've constructed our features, we then want to train a machine learning classifier to predict the labels or the annotations. And there are many different approaches to doing this. In some of my work, I've had a lot of success with fairly straightforward models like logistic regression and support vector machines. Others use random forests. And now, again, the most popular approach for text classification is to use some type of neural network or deep learning, because these models are able to, because they have so many parameters, they're able to learn really rich representations of text that turn out to result in very good performance. And once we've trained the model, it's then important to do evaluation and out of sample validation to ensure that the model generalizes to new contexts. So for those of you who know about machine learning and how to do text classification, this probably isn't very new, but I wanted to kind of walk you through the procedure for training a hate speech detection model to give you some insights into some of the potential issues that come up later on. So in my first paper on this topic, what we were interested in doing was distinguishing between hate speech and other kinds of offensive language on the internet. It turned out that a lot of the previous work on the subject wasn't really making this distinction. And so lots of content that was, potentially offensive, maybe it used certain words that were curse words or offensive in certain contexts, was being flagged as hateful just because it contains these words. And so we wanted to have a stricter definition of hate speech. So we defined a schema where we said there's, hate speech is language that's very directly targeting members of certain groups based on their identities and even inciting violence against those groups. Now, there might be lots of language online that we find distasteful and offensive, but it doesn't necessarily meet this bar. And then there's language that's completely innocuous. And so we annotated a corpus to distinguish between hate speech, offensive language, and content that was neither hateful nor offensive. And then we trained a model to predict these different annotations. And what we found is that the model was very good at distinguishing between hate speech or offensive language and content that was innocuous, right? We see in the bottom right here, 95% of the time, we correctly say that this content is neither hateful nor offensive. The model was also quite good at distinguishing offensive language from other content. And the main reason for this is most annotators consider things to be offensive if they contain a curse word or a slur. So you actually only need a fairly simple model to detect something like offensive language. You could even get, just a dictionary probably get you reasonably far in this task. But to distinguish between hate speech and offensive language, it's much more difficult. So our classifier was only correct about 60% of the time. And so most of the errors were to do with the classifier being unable to distinguish between hateful language and offensive language. And we found some interesting results when we looked into the actual cases where the classifier itself was confused. So in some cases, there were tweets that we felt were quite hateful that the annotators had only considered offensive. And so it seemed like the machine might have been better than the humans in some of these cases. But there were certainly others where it was kind of the opposite result. And clearly the human annotators were able to detect some sort of nuance that our classifier missed. But this paper really showed that we can do much better at this task if we want to make finer grained distinctions between different kinds of offensive language. And so building on this work, along with some other colleagues, we developed a typology of different hate speech and offensive language detection tasks. And here we make a distinction between two different aspects of online speech. The first is whether a statement is directed towards a particular individual or is something very generalized. This is from our paper. I've kind of edited it here to remove some more extreme slurs and examples, but still to give you a sense of the types of language that we were looking at. So a generalized statement might say, all of these people are losers, but not specify who these people are. In contrast to a statement, in this case, we can see that it's directed towards a particular user. So there are different kinds of hate speech that people use online. And then they vary in terms of how explicit or implicit the hate is. Now, explicit hate speech is often quite easy to detect because there's some sort of slur or other signifier that's very obvious. Implicit abuse is much more difficult to detect. You really need to know more about context. This is really where dictionary methods are going to do really badly. And maybe we need something like word embedding, something that captures more information about context. And recently, there's been a lot of innovative work in this area, considering not just text, but other types of visual cues. So researchers at Facebook developed a data set of hateful memes. And you can see in this case that we have these images with text overlaid. And again, these are kind of innocuous examples, but their data set contains much more extreme kind of real world examples of this. But in this case, you can see the images themselves are not offensive, and the text on its own is not offensive. It's only when you combine the two that you get something that becomes offensive. So in this case, we have this picture of a skunk. So it's implying that this person smells bad if you put the picture and the image together. And so there's some interesting work kind of combining images and text in more sophisticated kinds of models, particularly since lots of the ways we interact online now are mediated through image and video. So this is becoming an increasingly important domain to study. For those of you who are interested in kind of learning a bit more about these methods and perhaps training a classifier using our data set, I'll just point you towards this short piece I wrote up with Alexandra Schofield, who's a computer scientist. And we show you how to kind of go through code to train a model using Python and look at the effect of different features on the model performance. It might also be a fun task if you're learning R to translate some of our Python code into R. It should be fairly straightforward to kind of perform this task using something like tidy models. So that's kind of the first part of my talk, introducing hate speech detection. Are there any questions or clarifications before I kind of proceed into the next part?
Can I ask a question, please?
Yeah, of course.
Thank you very much, Professor Davidson, for your interesting presentation. I was thinking about the memos that you presented in the previous slide. Some of them are just fun, for me at least. So how we can distinguish between like just those fun things and just those that has the intention to be offensive?
Mm-hmm. Yeah, so the intent is something that's unobservable and very difficult to infer using these kinds of methods, and that's one of the problems I think that comes up in a lot of the ambiguity around these annotations is kind of inferring intent and the extent to which we can infer that based on social cues. So for example, maybe if we know people interacting are friends, we might perceive the content differently to if we know they're strangers. In this case, these are kind of very soft, very mild examples that I don't think anyone, they're kind of humorous. But there are other examples like this type of form that's a much more offensive, where we have an image and a video, an image and some text put together that ends up having a very racist message, for example, where just the image or just the text alone wouldn't convey that.
I see your point. Thank you very much.
Mm-hmm.
Hey Tom, I've got a question, but feel free, as you mentioned, it's hate speech. People would intuitively think it's easy to identify, but then it's actually a pretty hard problem. And so my take with, but I don't work on hate speech, but I do something about polarization, and then it's the same kind of thing. It's hard to teach. Like people, especially in the step of annotation, different coders might have different opinions about what counts as hate speech in your case. And then so that brings my interest to the annotation step. So how difficult do you find it is to get the coders to agree on the standard of calling some content hate speech, and then what kind of what kind of difficulties have you encountered when you do that process? How did you in the end come up with a code book? So it seems like you need to sometimes, like, we tend to list a different rules of, okay, so if it contains these words, that words, hate speech, but then sometimes there are always outliers or weird examples that it's hard to call. So just wanted to get your sense on the annotation step.
Yeah, that's a great question. So we definitely iterated in the instructions we provided to people. We found that having some examples that we assigned to different categories was very helpful for people to be able to see. Without examples, there was much lower agreement. And it's certainly the case that there are some messages that you'll see and everyone can agree it's very hateful. And these are often the easy examples that maybe a dictionary-based method will detect. And there are others which are much more ambiguous. We also, I suspect that, people's positionality and perhaps experience with either online content or hate speech or, experiencing some type of abuse or discrimination is going to kind of mediate how they perceive things. I'll talk a bit later also about, some other research that's been done looking at varying perceptions. So perhaps we'll come back to this towards the end.
Yeah, thank you.
And I think there was one question in the chat.
Thanks for the talk. I was just wondering, so we know that a lot of hate speech that happens online evolves really quickly. So like recent examples, at least in the US, I don't know if it's quite hate speech, but like, the whole Let's Go Brandon movement, where people kind of take innocuous statements, or like the OK sign that was like a white power symbol. So things evolve very quickly. So I was wondering, how effective are these models at actually then detecting newly evolving hate speech?
Yeah, that's certainly a major challenge, particularly if you work as a social media company and you're tasked with detecting this type of speech. The way people interact online is constantly changing, and so as academics, we often only have the resources to look at a small snapshot in time and collect several thousand examples and look at that and kind of move on. I think in practice, when people are implementing hate speech detection models kind of at scale, you get lots of feedback over time in terms of people reporting different content, other things being surfaced and identified. But it's always going to be a kind of battle, because there are people who are coming up with quite clever, innovative strategies to get around censorship. One example that comes to mind, there was a 4chan kind of plots, I think they call them raids, where people at 4chan were upset that Google had implemented a new set of words that were banned from certain, I think there were certain chat boxes that Google was kind of moderating using a word list. And so these 4chan users started using different words like Google or Skype as euphemisms for racial slurs. And so they kind of reappropriated the names of these tech companies and were using these in hateful ways. And there's been some interesting work looking at that type of reappropriation.
And another quick question by Jin.
Yeah. Hi, Professor Thomas. Thank you for your enlightening talk. I just wondered, what's the specific methods do you use to identify the explicit and implicit hate speech, and how do you identify the targeted and general online hate speech?
Yeah, so in that work, we were really proposing a theoretical typology, and other researchers have actually taken this up and operationalized it more. It's not something I've operationalized myself. I mean, targeted, at least on Twitter, should be fairly straightforward, because you can look at mentions and see if something's mentioning or if it's directly replying to someone. Whereas a generalized statement on Twitter, maybe someone just makes a tweet and they don't mention anyone else or mention any particular target. And so with digital trace data, we can often, identify various social cues to figure out how this language is actually being used.
Yeah. So I can see the specific methods from that paper.
In that particular paper I mentioned above, we just kind of provide some discussion of other work, but there are other papers. If you go on Google Scholar and look at who's cited us, there's some work where they've operationalized this. But I can't tell you off the top of my head the exact study.
Yeah, thank you.
Thank you. Okay, so I'd like to move on now and talk about the problem of bias in hate speech detection models. In general, these types of approaches are designed to detect speech online that often targets people from minority groups. But what we've recently found is that these models can actually be biased against the same groups they're designed to protect. So for example, researchers at Google had done an audit study of the Perspective API, which is one of the most widely used tools for detecting hateful and abusive content online. And they found that content that contained certain words that they call identity terms, and so you can see these words listed here. These are words that are, in theory, very neutral, that people use to describe their identities. You say you're an atheist or a lesbian or a Muslim. And what they found is that because these models were often trained using data where these terms were used in a pejorative sense, that models internalized these biases and ended up predicting that content containing these identity terms was more toxic than other kinds of content. And in particular, I focused on the issue of anti-Black racism in the US context, and how machine learning models designed to detect hate speech can end up being biased against racial minorities. So this example is taken from a paper by Martin Sapp and colleagues, and they look at how African-American English can result in toxicity scores that are much higher than when the same comments are made in standard American English. So on the left here, you have some examples of statements that are made either in standard American English or in African American English, which is a dialect. Now in African American English, and I think for many people, none of these statements are considered to be hateful or offensive, but these same statements that have the exact same meaning as something in standard American English get flagged as much more toxic by this Perspective API. And so in some of my work, we did an audit study where we took several different data sets that distinguish between things like racism and sexism, or hate speech and offensive language, harassment, hate and abuse. And we trained machine learning classifiers on these data sets. And we then took our trained classifiers and we used them to predict whether tweets were hateful or offensive or abusive, or whatever the outcome was in the data set. And we used a very large corpus of tweets that had been tagged already as containing either standard American English, which here we kind of call white English for short, or African American English, which is referenced here as Black for short. And what we find is that these different models all tend to predict that tweets written in African American English are much more hateful, offensive, abusive, racist than tweets written in standard American English. And we found this across every one of the data sets that we audited, including the one that I had helped to work on. And so this suggests that there's really systematic bias in the way these models are learning from these social media texts that are being annotated. In some subsequent work, I wanted to understand this bias a little more. And so I used structural topic modeling to train a structural topic model on an annotated corpus of tweets that have been flagged as being, in this case, it's the Founter et al. Data set, so hateful, abusive, or spam. And what we found is that certain topics in the corpus tended to be both racialized and tended to be associated with high hateful or abusiveness scores. So in this figure here, you can see there's one set of terms in the top left that's a kind of curse words that are associated with African American English, including reclaimed identity terms, that tend to be flagged as being very abusive compared to other kinds of curse terms, including very strong sexist terms, which generally people might consider a little abusive, but they tend to not be associated with very high abusiveness scores. So we used an inductive method to try to explore and identify bias in an annotated corpus. And so reflecting on these findings, I think there are really two major areas that we need to focus on to understand how bias enters into these models. The first is due to the way we sample data. And in particular, it's this issue of oversampling. So for example, in the data set that I helped to create, we initially sampled tweets based on keywords from the hate-based lexicon. And it turned out that that procedure led to the oversampling of African-American English because of the keywords we used. The other way that bias can enter into these data sets is through annotator biases. So perhaps the people who are tasked with doing the annotations are more likely to consider tweets written in African-American English a hateful or offensive due to their own internalized prejudices. So the issue of sampling bias is well known in the machine learning literature. There's a great paper by Joy Balamwini and Timnit Gebru that looks at bias in facial recognition systems. And they find that bias is largely a function of the fact that these systems are trained mostly on white male faces. And so when they look at classifiers, for example, to predict gender based on an image of someone's face, they find that these systems tend to make most errors when looking at faces of darker skinned women because there were not many darker skinned women in the training data to begin with. We can see these types of biases entering into unsupervised models, things like word embeddings, where we take a very large corpus of texts and we construct vector representations based on co-occurrences in these texts. And it turns out that these vector representations kind of represent human-like biases, which for sociologists has led to some very interesting research, because we can now represent much more complex types of things like stereotypes using textual data and kind of uncover different associations. So there's been some so the second source of bias that I'll talk about a little more is bias that stems from annotation. And so there's been some work over the years in the field of psychology looking at perceptions of things like hate speech, hate crimes, and racism. So this figure is taken from a study where participants were asked to look at a vignette and decide whether a certain situation in a vignette should be considered a hate crime. And the research has varied whether the target of a particular act was perceived to be black or white, and then looked at the effect of whether the person, the respondent in the experiment had high or low anti-black bias. So whether they were someone who kind of had racism towards African Americans based on a scale. And what they found is that people who tended to have higher anti-black bias were less likely to consider something to be a hate crime when it had a black target, and were actually more likely to consider something to be a hate crime when the target was white. And so I suspect that the same type of bias is occurring in the annotation of hateful and offensive content. For example, if social media companies are employing content moderators, it's possible that their content moderators are making biased decisions that are then becoming baked into their models. So a recent paper by Martin Sapp and colleagues kind of probes into this more deeply. It's a really, really fascinating study. I encourage you all to check it out. They take a corpus of tweets, and these are tweets where they've been established to contain anti-black language. And they look at how people decide to rate these tweets as either offensive or racist, and how this varies based on either psychological characteristics of the rater or the rater's identities, so their gender, their race, their political ideology. And they find these very consistent patterns that people, for example, who tend to be higher on scales like empathy and altruism and believe that hate speech is harmful, are much more likely to consider things to be offensive or racist than people who score low on these scales. If someone has strong racist beliefs or strong beliefs about the importance of free speech, they're much less likely to consider something to be offensive or racist. And they also find pretty clear evidence of the politicization of these issues, that people who tend to be more conservative are much less likely to consider these anti-Black posts to be offensive or racist. So they find lots of very interesting differences. An experiment by some of the same researchers tried to focus on ways to mitigate bias at the annotation stage. And so one of the things they did was a priming experiment, where before having people do an annotation task, they primed them on either dialect or race. So the prime was something like, you should be aware that people who belong to different racial groups tend to use language in different ways, and you should take that into account when you determine whether something is either offensive to anyone or is offensive to you personally. Similarly, they had a prime about dialect. And what they found is that by using these primes, people were actually much less likely to consider things to be offensive to anyone or offensive to themselves. So they were less likely to kind of make these racialized false positives where you would see something written in African-American English and say it's offensive just because it contains a word that you consider to be mildly offensive, perhaps. So that's one way we can think about mitigating bias. And I have some ideas for some experimental research to kind of build on this and better understand this process. Another interesting branch of research at the moment is focused on conducting audit studies. And so a really great paper by Paul Rutgers and colleagues developed a set of templates that can be used to audit an algorithm for hate speech detection. So some of the sources of false positives that commonly come up that might be flagged as hate speech when they really shouldn't be are things like positive statements towards certain groups where people might use a term like I love X, where X could be used in a negative way, and that gets flagged as hate speech when it shouldn't. Similarly, neutral statements that just mention a group identifier might be flagged because of that identifier. And a more difficult case is something like counter speech. So you can see an example here where they have a line that says statements like identity, and so this would be replaced with some particular term, are scum, are deeply hurtful. And so you have the hateful term, the hateful phrase identity are scum contained in this content that's actually saying this is bad to say this. This is very difficult for a hate speech detection algorithm to kind of parse out and appreciate this context. And so by developing these kind of vignettes, we can test our algorithms and see the kinds of examples they fail in, and then try to develop ways to make them better at detecting this kind of nuance. So this is another very interesting area of research. And again, I think this is a great paper. So I just want to wrap up by talking very briefly about some work in progress. So I'm interested in building on this topic and kind of really exploring how social context influence how we perceive hate speech, both in terms of the way we perceive a certain interaction online and our own social context as the observer. And so I'm currently working on designing a conjoint experiment where I want to show people examples of different types of interactions online and gauge how they perceive those interactions and whether they see them to be hateful or offensive or more innocuous. And so there are a few key aspects of the interactional context that I think are particularly important and haven't really been picked up in previous research. So far, we know about the text itself and something about the characteristics of the person making the annotation, but we don't really know much about the kind of the sociological dimension of how hate speech is being used on the internet and how that might inform people's decisions. So for example, if we manipulate the identity of the target or the victim of the speech and of the source and the perpetrator, how does that affect people's perceptions? There's been some research in this area, and certainly, we might expect that if it's a white person directing a comment towards a Black person, that's going to be perceived in a different way to two whites interacting or two Black people interacting together, or perhaps a Black person interacting with an Asian person. So there are different social contexts, in terms of the identities of the individuals. Also, we might consider something like gender or sexuality or political orientation. The second is the relational context. So I think it's pretty evident that speech between friends should perhaps be treated differently as speech between strangers, even if we might, disapprove of certain conduct in our own personal interactions. If people want to curse at each other online and their friends, there's not much we can do about that, and that's arguably quite different from people directing very hateful statements. And so how does the relational context and cues about the relationship between people in an interaction, or even things like the number of people in an interaction, or whether or not an interaction is repeated, how does that affect our perceptions? And finally, there's also this type of speech. There are other manipulations as well, but these are the main ones I'm interested in. And then we have the moderators at the level of who's perceiving the interaction. So we know from some previous work that demographics and attitudes matter. And another thing that I'm very interested in is how social media usage matters. So if you're a heavy Twitter user, it could go both ways, right? Perhaps you've grown a thick skin, you've seen lots of offensive content online, and your kind of bar is quite high. Or maybe you're very attuned to this type of content. And maybe you think, because you've used Twitter so much or used Reddit a lot, you're really good at perceiving when something is going awry and is potentially unwelcome type of social interaction. So I'm currently working on these experiments. I wanted to just show you a very simple vignette. The experiment will be a bit more complex than this, but to just give you some flavor of these types of decisions, and perhaps you can think about this example yourselves. So hopefully you can all read this. Maybe it's a little small, but we have an example of a direct message on Twitter. And so this person, Joe, sends a direct message. And Joe says, quit complaining and go back to your own country if you don't like it there. And we can see some cues about Joe's identity based on the avatar. And then the person responds and says, that's a really hurtful thing to say. So the experiment would involve seeing something like this and making a decision. Now, what happens if we have some other cue like this? Here we have a small difference. We have a different identity cue. Joe has said something xenophobic. In this case, the cue is not really about national origin, but maybe just this identity cue in this case is going to alter how we perceive this interaction. So maybe you've updated your belief and you might think that this is more clearly hateful after you've seen this type of cue. But then what happens if we see a more involved exchange like this? So in this case, Joe has already reached out. We have some other content. Did you see the show last night? Hey, Bob. And then this person who we now know is named Bob replies, sorry, man, I lost my phone. They reply a bit later on. And then Joe makes this comment. So how does this now change how we perceive this comment? Do we potentially see this as maybe bad taste, more of a playful interaction, that clearly these people are known to one another? This is perhaps different to someone DMing someone in this kind of unrequited way. And then the target here in this case responds, they seem to find the interaction funny. So I'm interested in kind of developing these more realistic scenarios that had various different social cues, and then assessing how these impact our judgments. And hopefully this can inform content moderation policies and help to have more socially informed decisions, and perhaps even have machine learning models that can incorporate more features related to social context. So that's all I have for today. I'm really looking forward to your questions and comments. Had some great questions already, so I'll leave it at that. Thank you.
Thank you so much, Tom, for this very inspiring talk. Especially I like your talk because you not only introduced your own work, but also introduced a set of great work across various disciplines working on this subject of hate speech, so that I think participants might be able to see what kind of topics they can really work on and apply to their own work. So for that, I really appreciate that. Yeah, I think so the later part of talk should have generated lots of interest among us. So please ask any questions to Tom. So I see the chat box here. So I'll give Hao Huan an opportunity to ask.
Hi, Tom. Thanks again for the nice talk. So, my first question is about the precision recall of hate speech detection you mentioned at the very beginning. So, I mean, as we know, there's a trade-off we're facing here, like getting and like some we might having too many false positive or too many false negative, like if we choose models and color points one way or another. So, what would be the and then here, there's a question for the academic. It's like when you choose a different sensitivity of hate speech detection, what would be the consequence of the research outcome for researchers, and then also for practitioners? Like if you're deploying that algorithm for, say, a social media platform, what would be the risk of choosing different sensitivity of this hate speech detector, and then what's the best practice you would recommend? And so that's the first question about this precision and recall. Do you see the trade-off there? And then what would be the best practice? And then the second question is about the second half. So one thing I get from, maybe it's like one thing I get from what you're sharing is that sometimes the detection of hate speech, it should be contingent on the identity of the speakers. Like sometimes the use of some word, it could be racist for if the speaker is not, say, African American, but maybe if the African American are using these words, they might not be. So does it suggest, if we're doing hate speech detection as researchers, we also need to make use of more data relating to the identity and the demographics of the speakers themselves to make a more accurate call? And so what should we do if these information are not available or and not accurate? So thanks.
Thank you. Really great questions. So maybe I'll start with the second question. In terms of identity, you're certainly right that in different social contexts, using language is going to be perceived as offensive for one group and non-offensive for another group, right? There are certain words, racist terms, homophobic terms, sexist terms that in some contexts are completely acceptable everyday parts of language from people who are members of these communities. I don't want to really get into the business of adjudicating when it's right and wrong to use different kinds of language and kind of policing when people should and shouldn't. I feel like my job as a sociologist is more understanding like when people make these distinctions themselves. I do think that having some identity cues can be helpful for hate speech detection. For example, if we want to, I do a lot of work studying anti-Muslim groups in the UK, and it might be helpful to know if someone is Muslim or not to understand their comments on Facebook. If we think they're from a targeted group, it's probably pretty unlikely that they're using Islamophobic language. The danger there is that we end up, our models might end up relying on these features, that we end up kind of discriminating against certain groups because we have these kind of social or identity-based features in our models. And so that's certainly a challenge that I'm not sure that there's a good solution to. But certainly, if we have social information, then we might want to see how different kinds of speech vary according to different groups. In terms of the question of precision and recall, so how does this matter for our models themselves? Well, if we have a very high precision model, we're going to be very confident that what we're detecting and saying this is hate speech is actually truly hate speech. But what we often sacrifice if we have a very high precision model is we might lose some recall. So maybe there are some borderline examples that really should be considered hate speech, but we're not so confident in those examples. And so we say they're not hate speech, and so we miss them. And so often having a high precision model means we have lower recall. If you want to get high precision with a dictionary, the key really is to have a small dictionary. So maybe you have, a set of 2 or 3 words that you know are almost always going to be extremely hateful, then you can fairly, make a reasonable assumption that what you're detecting with those keywords is going to be hateful, although you may still get things like counter speech where someone mentions that someone was hateful towards them. Having a high recall approach means you really want to capture as much of the hate speech as possible and not miss anything. But often when we have higher recall, we really sacrifice precision. And so we end up flagging lots of stuff that's not hateful as hate speech. And so the kind of strive towards higher recall, I think, is one of the reasons we see things like racial bias, that we end up, our models are oversensitive and they flag language that really should be more nuanced and consider it hateful when it's not. In terms of how researchers should approach this, for example, let's say you want to do a study and look at hate speech in an online community and kind of quantify how much hate speech there is. I expect different people will give you different answers. I would kind of err on the side of having a more precise measure and kind of sacrificing some recall. And, at least if we can measure some hate speech very well, maybe we use that as a proxy, even if like the true rate is somewhat higher. So if I want to look at something like anti-Muslim bias, maybe just having a few keywords and looking at the frequency of those keywords over time, that's going to tell me something about the dynamics of a community, even if the actual, the actual trend line is slightly higher than what I'm observing.
Thank you, Tom.
Okay, next, Song, you can speak.
Yeah, hi. Yeah, so I was kind of curious about exactly how you were planning on or defining identity, especially using sources like Twitter, where it may not be as obvious. It almost seems like if you were to try and train a machine learning classifier on just like tweets, it seems almost as difficult as identifying hate speech, and you'd be fraught with like the same kind of biases and issues like identifying race from face, or identifying sex based on the different racial profiles of the images. Yeah, so I was just wondering, how do you plan on doing that?
Yeah, I mean, the goal is to find identity cues that people are going to perceive as representative of certain identities. So there are certainly issues involved with people making assumptions based on someone's appearance about their ethnicity or their sex. But for this type of experiment, the goal is to kind of trigger those types of cues. So what I plan to do is, this example above is a little simplistic, but perhaps we could show an image of a face that signals something about race and sex, and then perhaps we might have other cues, like here we have a cue that represents something about politics and a cue that represents something about sexuality. Now it may be the case, people certainly use something like a pride flag to show their solidarity with the LGBT community, and so it's imperfect, but the goal is really to see how these different cues are going to affect people's decisions.
Okay, yeah, I guess that makes sense. All right, thank you.
Okay, next, Han.
Hi, Professor. Thank you for your inspiring talk. You mentioned in some of your study that you are using tweets from Twitter to detect hate speech or to test other relationships. So I was just wondering whether you are using data from other like social media platforms like Facebook or Instagram. It's so you also mentioned that some context specific variables could influence how people perceive hate speech, or they talk about that like relational context and other identity issues. For me, it does make me feel that the platforms might also be a context factor, especially people might have some like platform specific language. So I was just wondering whether you collected data from other social media and tested your like precision, robustness with other platform data. Yeah, thank you.
Thank you. Yeah, I mean, I suspect there are quite strong platform-specific differences and perhaps norms between different platforms, right? Somewhere like Reddit that's much more community-based might have different community-based norms to a platform like Twitter. And something like Facebook is much more about the more immediate social context. And again, the norms will be different. So, you know, one of my plans, whether I'll get this done in the initial experiments or not, I'm not sure, but would be recruiting people from different social media platforms as a way of looking at how, you know, someone's familiarity of a different platform kind of shapes their perception, and perhaps seeing whether what we learn on Twitter generalizes to other platforms. In some of my other work that's unrelated to hate speech, I do compare Facebook and Twitter and find quite different results. And, you know, I feel quite strongly that, you know, we shouldn't generalize anything about, you know, one social media platform to another. In my work on hate speech, I've largely focused on Twitter, and the literature in general is very Twitter-centric, in part because Twitter data is just very easy to obtain. I think that's really the main reason people study Twitter. And certainly in this context, right, tweets are quite short. And so the type of inferences we can make on tweets might be quite different to something like Reddit or Facebook posts, which could be much longer. So I do suspect there'll be, you know, differences that we might pick up in a machine learning classifier based on something just like the amount of text we have.
Thank you so much.
Okay, thank you again, Tom. So I think the number of questions generated already proved that your talk was really interesting and inspiring in some ways that would eventually help us do group projects later on. So thank you again, Tom, for your great talk, and especially for your time in the evening, right? So I hope you have a good night. So yeah, thank you.
Thank you very much. It was really great to virtually meet all of you and to have all of your questions and feedback. And yeah, best of luck with the rest of the event.
Okay, thank you so much.